Hi, I'm Scott Bradford from the Rio Grande Jewelry Tech Team, and today I'm going to show you how to set up and use the eLUXE3D Platinum 3D Jewelry Scanner. So let's get started. First, let's take a look at everything that's included with the kit. We have the 3D scanner, we have the power cord for the scanner, USB cord for plugging into your computer, we have a calibration plate for calibrating the unit, a can of scan spray, jewelry cleaner to remove the scan spray. We have a rotating platform for placing your models while you're spraying, so you can spray in 360 degrees. A USB stick containing two pieces of software you'll need to install on your computer, one that collects the scan data and the other that stitches them all together. Currently, this is only Windows compatible. And we have our various fixturing options to get the piece that we're scanning into frame. So the way these work together is they are all magnetic. You can see magnets on both sides, so you can mix and match these however you wish. This platform is actually magnetized as well. So the vise that's included with it will stick into place and you can move it however you wish. Same with these clamps. These can be attached to the magnetic base as well. This base here also has magnets, but it has a blue tack type material that you can push your pieces into to hold them. We have some kind of sticky wax type material, and also some gum pads that you peel off and you can stick anything you want to these. So you have a lot of fixturing options that you can mix and match. Same with this. This is kind of a tacky type material that you can pull off and use to hold any piece you need. So yeah, you can mix and match these however you need to get the piece you want to scan into the frame. So to set up the scanner, the first thing we're going to do is we're going to plug in the power cord and then plug that into the wall. And second, we're going to install our USB cable, which will go from the scanner to a USB port on our laptop. Now that we have everything plugged in, we can turn on the power, and we'll want to let this warm up for about 20 minutes before we use it. So now that the machine's been on for about 20 minutes, the first thing we need to do is we need to calibrate it. You only need to calibrate this machine when you initially set it up the first time, or if you're moving it to a new location. You don't have to calibrate every time you use it. So to calibrate, we're going to use this calibration plate that comes with your accessory kit, and it locks into the platform with these two magnets. So we're going to set that on the platform and make sure that this side is turned towards the camera. So now we're going to go into the software. We need to boot up the eLUXE3D software that came on our USB stick. So once you have it booted up, the first thing we need to do is we need to go into the settings. And that is where you'll find the calibrate button. So I'm going to click on calibrate and click next. And we will let this run until it's finished. Okay, now that it's done calibrating on our software, we can click the finish button, and now we can remove the calibration plate from our platform. So this is the ring that we're going to be scanning. It has a kind of a zigzag pattern on top, and we're going to make a band that will fit right up against this ring. So this ring actually makes a really good candidate for 3D scanning, so that way we don't have to fabricate all these little zigzag parts and make it fit in really nice. We can do that just with the scanner. In fact, the scanner works really well for making shadow bands, making a mirrored copy of a lost earring, or even scanning odd-shaped gemstones that you want to make a CAD model for. So the way I'm going to mount this ring into our scanner is I'm going to use the vise. So I'm going to just mount it in the vise very gently, and then I'm going to mount the vise to this magnetic platform. But first, before I load this in the machine, I need to spray this ring with scan spray. The reason is that scanners, they don't really know how to interpret something that is partially transparent or highly reflective. So the scan spray is going to dull the surface so the scanner can collect more data about the piece that we're scanning. So with scan spray, less is more. Adding more scan spray than is needed will actually build up a texture on the surface which will come through in your scans. So we're going to just do very quick and small spritz of the scan spray. And that will take a few seconds to dry, but that will mat the surface enough to where we can collect lots of data from this scan. So before we start scanning, let's take a look at some of the settings inside the eLUXE3D software that we're going to need to adjust. So in the settings menu, where we found our calibrate button, you'll have a few things you need to take a look at. So first, here along this line here, we have 4 different file formats that we can export out as when the scan data is collected. So we have PLY, STL, OBJ, or the raw point cloud data. So for now, I'm going to only use STL, and that will be my output format for the scan data. Your save folder is important. This is where, when the scan is collected, this is where the scan data is going to be put. So select a folder on your computer where you like to save stuff, and make sure that that is here. You can change the folder by clicking on the 3-dot button right here. On the next tab up here at the top is our scan size. So this is where we need to estimate how big the piece is that we're going to be scanning. So as you can see, different sizes require different settings, and also have more RAM that is needed to calculate it. If you don't have the required RAM, say 16 gigabytes, it will still work. It just may go a little slower. Since we're doing jewelry, I'm going to check the super resolution down here at the end for a small size piece, and leave that there. Next tab is our scan angles. So this is going to plot the course of the platform and determine how much scan data we're actually going to collect. So there's a drop-down box here for presets. I'm going to click on that. And a good place to start with scanning is to go to standard. So what that's going to do is it's going to do kind of a short standard run to see, and we'll see what it collects when it scans. You also have some that are a couple down here that are very dense. You can see as it's reflected on this little graph here, this one takes a lot more data per scan. So for now though, let's leave it on standard. The scan will probably take a few minutes, and we can see what we've collected. So the next tab here for scan settings. Most of this stuff you won't need to adjust. It gives an explanation as to what you're adjusting. I actually like to turn mesh density down to low. That's going to make sure that The files that I'm collecting are not that big. They're not going to take up a lot of room on my hard drive. And if I need to down the road, I can always bump that back up. In the last tab in the post-processing, you have some basic settings here for eliminating noise and trying to smooth the model, that sort of thing. We really don't need to adjust anything in here. It will actually start the post-processing after the scan data is collected. So for now, let's just leave these at the default. So that's all we need to do in our settings tab. So I'm going to go ahead and click OK. And now I'm going to name the scan. So I'm going to call this ring scan 1. And I'm going to click on the scan button. Now what that's going to do is it's going to start the camera so we can start to fixture our item on the scanner. So next I'm going to use the magnetic base, and I'm going to put that onto the platform and get the magnets to line up, and then put my vise on top. Now I'm going to be working from the computer screen as well, because as you can see in our software, now we can actually see the ring and we can make adjustments as needed. What we're looking for is we want the entire piece to be visible as this platform moves. So I can move this manually with my hand and even rotate it to make sure that this ring is always going to be in the camera view the entire time. So I'm going to start with something like this and line this up with the crosshairs the best I can. And last thing we need to do is down here at the bottom is a button called manual exposure. Go ahead and click that and you'll be presented with this slider. So we're going to slowly start bumping up this slider, and you can see the effect that it has. And this is what we're looking for right here, is this kind of pink artifact on the piece. If I turn it down once, you can see I've got a little bit of a flicker here. That's kind of what we're looking for. We're looking for very minimal kind of this pink artifacting on the screen, and that's where the exposure really works best. So next thing we can do is just click the next button and the scan will start. So now the post-processing is complete, and let's take a look at what we got. So the other piece of software that is on the USB stick is called EasyScan. And this is the software that's going to allow us to stitch everything together. But we're also going to use it just to inspect the data that we got from our last scan. So up here at the top left icon, I'm going to click on that and click Import. And I'm going to locate my folder that I saved these files and bring in that STL file. So the red areas are areas where it did not collect scan data, and you can see it also picked up the vise as well. We're going to be cutting that away when we start stitching everything together. But now we can clearly see the areas where we're probably going to need more scan data. So especially out here on the edge of this ring, and then we'll do our best to get as much data as we can on the inside of the ring shank here as well. So now I'm going to go back to my scan software. I'm going to create another scan. We'll call it Ring Scan 2. I'm going to click on the scan button, and now I can start to get my ring resituated. So we need data from this under section here, so I'm going to flip this ring over, and I'm going to mount it in the vise, upside down, and now we're going to recoat it with our scan spray. So now I'm going to put this back on the platform here. So I'm going to go ahead and line this up according to the crosshairs. Make sure that manual exposure box is checked, and then bumping up that slider until you just start to see the kind of pink artifact. If you see a lot on your screen, that's not a problem. You mainly want to adjust this slider down until you can get the minimum amount of this kind of artifacting on the screen. So now that we have everything situated, we can take a quick look to see if everything is going to be still in camera view as it moves. It looks like we're good. So now I can just click the next button and it'll start to scan. And now that our scan is complete, I'll go ahead and click the finished button to start the post-processing. So now that we've collected our second set of scan data, now we're going to go into the EasyScan software, and I'm going to show you how to stitch these scans together to create a full 3D model. So now that we've collected some scan data, let's learn how to stitch it all together. So I've already imported one of my models into the EasyScan software. So now I'm going to import the second set of scan data in. So I'm going to click on this top left icon, go to Import, and bring in my second scan. Now on the left side of the screen, you can see my two scans here. And these boxes next to it allow me to turn each scan on and off individually. Now the first thing I need to do is I need to remove this vise from the model. I'm not going to need that. So in this window, by default, you already have the lasso selection tool. So what that allows you to do is it allows you to draw around the geometry that you don't want to highlight it, and then you can delete it. So for this vise piece here, I'm going to draw around, going a little bit over the edge to highlight all that, and then hit delete on my keyboard. And I'm going to do the same thing for the other scan. So I'm going to bring that one in, hide the other one, and I'm going to start drawing around this one to highlight it, and then click delete. So now I've got that vise gone, and I can start stitching these together. So I'm going to turn both of them back on. I'm going to select the top scan and then go to this icon here for manual align. Now when we click on that, you can see our first scan that we clicked on is down in this aligned section down here with a window that we can now move. Now here you may see that my models, you can't actually see my model, but when I hover over it you can see it. Just make sure to click on that to highlight it, and that will show it in both screens. So what we're effectively doing is we have this scan up here, we have this other scan down here, and then a viewing window on the right to see how they're all lining up. So the first thing I'm going to do is kind of roughly get these into a similar orientation. So let's see if we can find which direction they're supposed to be. That looks right. So now what we need to do is we're going to find common areas between these two scan models to say this point here aligns with this point here. So I'm going to click on the model in this place, and then in the same place on the second model I'm going to click again. You can do an upwards of six dots to kind of line everything up, and we just need to find those kind of common points and click on them on both models. So I'm going to click on that corner and that corner. You can see we're getting a little closer. We're going to need a few more. So how about we do something on the side here and then something on the side here. Take a look at it and see that's pretty close right now. It's not perfect, but when we actually merge these scans together, they will line up a lot better. So I'm actually going to just leave it just like that. I could mess around with some more points. Like I said, you can use 6 points to kind of line everything up. I could even do another corner here and see if that helps a little bit. Yeah, not much. So we're just gonna leave it at that. When we get it how we want it, we'll click the apply button, and that will put those together. As you can see, I've still got some holes. This red here indicates that there's a hole there, and that's just because it didn't collect any scan data in those areas. So once I get these two lined up how I want to, and I click apply, I can click close. It'll ask me if I want to apply those changes. Make sure to click yes. So now we have these two scans lined up the way they should be. Now, if I wanted to try to fill these areas in, I could go back and try to collect some more scan data to try to get these areas in the scan. So that way I could stitch them onto this model and kind of clean those up a little bit. Or I can use the tools available inside EasyScan to just go ahead and patch them, which is what we're going to do. So now that we've got these two scans aligned, I'm going to highlight them both. So I'm going to hold Shift and click on one and then click on the other. We just want to make sure that both of these are highlighted. And then we're going to click the Merge button. This box will pop up asking if you want standard definition, high definition, or ultra high definition. And there's a few options here for different boundaries. Boundaries are these little edges around the holes. We're not going to mess with those just yet. Create watertight model. We're not going to mess with that right now because we need to patch these holes. If you get a good scan where pretty much everything is filled in, you can go ahead and click on create watertight model. But for now, we're going to leave that unchecked and just leave it at the defaults. So I'm going to click apply. So now in our list, we have a new model here. So we still have our two original scans, but now we have this merged model here, and we need to go in and fill in some holes. So I'm going to highlight that new scan and navigate down to this option here for fill holes. And when I click on that, I'll want to click the Find button to find where the holes are at, and they always get highlighted in yellow. You can now click on the edge so it turns red and click Fill. So it will do its best to try to fill in that hole, and in some cases you'll get a bit of kind of puffiness where that hole is being filled in. That's mainly because it's a larger hole. So it does its best, but we may have to clean that up in our CAD software later, or try to go back and collect some more scan data to more closely fill that in. It's up to you on how you prefer to do that. So if I like what it's doing, I can just click apply, and now it will add that into the model to patch that. So I'm going to click Find again so I can highlight this hole up here, select it so it turns red, and then click Fill. And same thing, probably getting a little bit of puffiness, but I can always touch that up in my CAD program later. So it looks like we've got a few small holes. I'm going to go ahead and fill those in as well. And if you want to select multiple holes, you can hold Shift while you're selecting these to highlight them all. Click Fill and Apply, And there we go. So now we can actually fill in all those holes, and now it is a solid watertight mesh. So there are a few other options in EasyScan that you can take advantage of. There is a decimate command to actually bring the amount of geometry down in case you try to bring this into your CAD program and it kind of makes your CAD program chug a little bit because it's a very dense model. You can use the decimate command to bring it down, and you can see just how much geometry there is in this mesh. So right now I have about 260,000 polygons, which isn't too bad, but we can bring that down if need be. There is also a smoothing command. So if I launch the smoothing command, you can input a value in here and see what kind of effect that has. So I've got mine on 20 right now. Let's click apply and just see what happens. So you can see it kind of smoothed out a little bit. Be careful with the smoothing command because it will smooth out everything evenly. Not taking into account things like stone settings or corners or things like that. So just be careful going too far with the smoothing command. It's up to you on how much you want to do that. I'm going to go ahead and apply that though, and then click close. So a few other options, delete small cluster. Sometimes with scan data, you'll have some little bits of geometry just kind of out here on the edges. You can use the delete small cluster to actually find those and just delete them in bulk. That's really all that command is designed for. Shrink boundary, that's mainly for kind of patching things. We're not really going to use that too much, but that's kind of what that's designed for, is kind of cleaning up those boundary lines where you have open, where your model is still open. Reverse normals, normals actually refer to the directionality of surfaces. So if you were to export this out and find that something was missing or the model just doesn't look right, it could be an issue with your normals, but more often than not, you won't have to mess with that. We've already filled our holes. The last thing we need to do is just export it. So when we click export, we can give it a name. So I'll call it RingScan STL. Select your file format from either STL, OBJ, PLY, or an ASC file. And there we go. Now we have created the scan, we have stitched it all together, and now we have a workable STL file that we can use for reverse engineering, for making a shadow band, or whatever we need that scan data for. Thank you for watching. Make sure to like and subscribe, and if you have any questions, feel free to contact us.